Today we're going to learn about perfect squares. Now the reason I had you write this down is for you to be able to go back to know that 13 squared is 169. And if you come up with 169, you know you can break it out into 13 and 13. Perfect squares are going to have the exact same number. These are all right here. These are what you consider your perfect squares through 13. Okay, so if you have 100, you know you have 10 times 10. If you have 81, you have 9 times 9. If you have 25, you have 5 times 5. Are y'all with me on this? So this is kind of just like a guide that you're going to keep with you. So let's talk about perfect squares. What are perfect squares? Well, yesterday we talked about the difference of squares. And the difference of squares where you had a squared minus b squared, and it equaled a plus a and b minus b. Well, today we're just going to see it written like this, where you have a plus b and you square it, and then you have an a minus b and you square it. So if you pay attention here, if you have a plus b squared, anything squared is that times itself. So we write out a plus b times a plus b, and we FOIL it. And what you're going to get is you're going to have these two like terms here in the center. All right? A minus b squared, we're going to have a minus b times a minus b. And then you're going to have these two terms, but now it's a negative. Do you see that's the only difference right here? Okay. So because a negative times a negative is a positive times a positive, that's why our b squared is positive. But this one is a positive and that one's a negative. So factoring perfect square trinomials. So we have an a squared plus 2ab plus b squared. It's going to come back down to this a plus b times a plus b. And then we're just going to put that together and put a little square next to it. All right, so we're going to work backwards. We're going to start with this and we're going to get to this answer. Where up here it starts with this and goes to this answer. All right, so we're working backwards. What are we going to do? We're going to use the x factor. We're going to find the GCF. We're going to factor. So here we go. It says determine whether each polynomial is a perfect square. Now listen, a perfect square has the exact same terms in both. They can't have a different sign. They have to be the exact same term in both sets of parentheses. So if we have 9y squared plus 24y plus 16. Okay. I am just going to start with x factor on this example. Okay. So I have a equals 9, b equals 24, c equals 16. All right. So we're going to do my little x factor here. 9 times 16 is what? Huh? 144? Okay. A perfect square. You can list them out if you want to. But you have to figure out what is a number times a number to give me this, and can I add to do this? So this is where this comes in handy. So if you look at this, 144. 144 is 12 squared. So 12 times 12 is 144. 12 plus 12 is 24. So look, it works for us. Okay? So we're going to use 12 and 12. Okay? Now, that gives us y plus 12, y plus 12. What is the very important step you have to do at this point right here? Divide by my a term, right? My a term is 9. So we are going to divide by 9, divide by 9. I do what then? Do I leave it at 12 over 9 or do I simplify? And what is 12 over 9 simplified?
4 over 3.
4 over 3. All right. Then you can take this term and move it up front. The denominator moves up front. And so you'd have 3y plus 4. 3y plus 4. Is that a perfect square?
Yes.
Yes. we good? Okay. I did give y'all, I just noticed this. I gave you your perfect square list on the very back of your notes. Sorry about that. I just saw that. Okay. Number 2. 2a squared plus 10a plus 25. A equals 2, B equals 10, C equals 25. 25 times 2 is? Add to get 10. So look at your perfect square list, right? Because a perfect square is going to be a number times a number. There's a 49 and then a 54. So is 50 a perfect square?
No.
Nope. So the answer is no. It's not. Because it is asked, are they perfect squares? This one is not a perfect square because you cannot find a number times a number to equal 50. The same number times each other to equal 50. Okay? That's how you do that. So let's go on to the next thing. Factor each polynomial if possible. If it cannot be factored, write the word prime. So this one says, hey, I want you to use the Gcf method. All right, so here we go. That means we have to do what? We got to factor this out. Okay. 2x squared minus 32. So really the only thing I need to factor out over here on the side is 32, right? So let's take 32. Here's my little scratch notes. 2 and 16, 2 and 8, 2 and 4, 2 and 2. So I have 2 times x, then I have 1, 2, 3, 4, 5. 2 times 2 times 2 times 2 times 2. Okay? What is my GCF? 2. Okay, so we write. What I'm noticing is a lot of students still are not seeing, once you pull out that GCF, what is left? X times x is?
X squared.
Okay, now minus, because remember there's a minus sign right there. 2 times 2
4
times 2
8
times 2.
16.
Okay, now we have to figure out, is this a perfect square?
Yes.
So look at your chart. Well, x can be pulled out to x and x, right?
Yes.
Is 16 considered a perfect square?
Yes.
What are my two factors?
4.
4 and 4. So we have 2x. It's x minus, nope, it has to be x plus 4, x minus 4. So this becomes a different of squares using the perfect square method. This is an example they gave me in the book to use. Okay, because we're using perfect squares to find it. Now, why was this considered a difference of squares? Yeah, it was an a squared minus a b squared, wasn't it? Okay, so it's called difference of squares, but you use perfect squares to solve it. Okay, so the next one I think is the same example. I mean, it's kind of the same thing. It's going to be a difference of squares. 5x squared minus 80. So let's factor out 80 here. We have 2 and 40, 2 and 20, 2 and 10, and then 2 and 5. 5 times x. And then here, 2 times 2 times 2 times 2 times 5. So what is our GCF?
5.
5. What's left? Minus, what's 2 times 2?
60.
Oh, it's going to be 60. Yeah, y'all did all of it. That's fine. So look, I have an a squared minus a b squared again, don't I?
Yes.
I'm using perfect squares. 16 is a perfect square. So I'm going to end up with x plus 4, x minus 4. Is everybody good with that?
Yes.
Okay. So now let me show you the the square root property. All right. If you have x squared equals 25, how are we going to solve it? What undoes a square?
Square root.
Okay, look. So we're going to square root x squared, and we're going to square root 25. So that leaves me with what?
X equals 5.
X equals 5. Now hold on. Hold on. With a square root, there's actually two answers, and I want to show this to you. We're fixing to start getting into where you see a plus or a minus square root. Okay, why? Negative 5 times negative 5 is what? Positive 25. 5 times 5 is positive 25. So your x is actually a positive 5 and a negative 5. When you take that square root of 25, you get 5, but you can do a negative 5 or a positive 5. Okay? So when you see the answers are going to say plus or minus 5. So the only difference, when you have a square root, we're going to put a plus or minus sign in front of it. That's it. Okay? Because square roots are both the positive and the negative of that number. So let's look at this one. Y minus 6 squared equals 81. Okay? If they're asking you to use the square root property, what you're going to do is we're going to say the square root of y minus 6 squared and the square root of 81. Okay? So the square root undoes the square. That leaves me with y minus 6 plus or minus the square root of 81. Is 81 a perfect square?
Yes.
What is it?
9.
9. Y minus 6 equals plus or minus 9. Okay. Have I solved for y yet, though?
No.
No. So what am I going to do? I'm going to say y minus 6 equals 9. And y minus 6 equals negative 9. I'm just going to split that up into two different equations. How do we solve this one?
Add 6.
So I get y equals. And then here, what do I do? I always pay attention to the screen. I'm not paying attention to this, so I write, and the people watching the video can't see. So negative 9 plus 6 is what? So your roots slash solutions, however they want to say it, is negative 3 and 15.